Hi, I'm going to pick up kind of where I left off last time with the utilities. I'm going to go through a few more utilities this time, and then I'm going to probably add at least one more utilities video before moving on to some of the other modeling aspects of the software. So last time I ended off at the event restoration, so today I'll start with data conversion. So here in data conversion, you can give it the input directory where your files are, or if you've already created a list file, and you can build the mini seed file list here. You can view the segd, seg2 info here, but you can build a list the same way you built before when you're creating projects. And then you can choose to either convert from segd to seg-y. Segd is the general field format, so that's probably one of our more useful ones. Seg2 to seg-y, you do see some seg2, for instance, I don't know if they still do, but Halliburton with their .dat files, those were seg2, so you could use that to seg-y. And then MRF, which is a less common format, you can do that to seg-y. Mini seed to seg-y. So mini seed is the format you generally see if somebody for like a passive seismic network for a state or nation, like Pennsylvania in the United States has a whole network for the induced seismicity to which comes out in mini seed files. So you can access that, and public databases often use that. So you can also put your station file or channel file in here if you want to. So I've generally used this for conversions for just vertical microseismic projects. So I really haven't had to use a station or channel file. Yeah, you could allow the maximum allowed number of samples. I don't usually limit this, but if you had really long records, I guess you could. Traces skipped. If you know there's a certain number of bad traces at the beginning, you can skip those. And then just your output directory where you want to output the converted data. So like I said, the majority of this that I've done has been segd to seg-y and a little bit of seg2 to seg-y. Okay, the next couple of utilities I'm only going to touch on to say I really haven't had to use them. In general, for downhole microseismic, statics conversion isn't necessary. I I know that we've used it before for very rarely just to test it for a statics conversion for a surface microseismic job, but I've never had to use it for a project. And the convert twos complement integer, I haven't had to use that either. So if there's questions about these, I can go back and dig into these more, but I'm not going to spend a lot of time on something that I've never used here, and I don't think it's going to come into play that often. Sorting components. So again, if you input your seg-y file list you built here, if essentially if the here in the for MiVu we process everything in the ZXY order. So the only time I've really had to use this, and I have had a couple times, is sometimes you'll get people that don't that their recording system doesn't put the vertical channel first, so you get XYZ, and all you got to do is say if XYZ was your actual component, instead of putting input order ZXY here, so for Z you would put 2 because it's the third one, and then you would put 0 and 1 here for X and Y if you had an XYZ, and then just keep it the same because if you want to have it come out in the ZXY order here so you can use MiVu to process it, then you would just keep this the same. Okay, so next I'll go on to merge seg-y files. This is kind of an interesting option we have here. I haven't seen this happen all that frequently, but you will occasionally get data sets that are output in where you get 3 volumes where one is just the X component, the horizontal 1 component, Y is the horizontal 2 component, and Z is the vertical in some order or another. But in this case, as long as you tell it, give it the list file, you can capture the files or give it the list file for the XYZ components and make sure those are correct, and you give it how many number of shots or essentially number of records there are, it will output your shots in the correct order. I believe this is, I'll look into this, I believe this is a misprint. I believe this should say ZXY because that's our standard format, but I'll look into that. Let me take a note right here. Okay, and the last one that I'm going to cover in this utility is the merge multi-whale seg-y files. So if you have say you have like a three vertical array set up for a microseismic job you're doing, which we have had quite a bit, and you just tell it you have 3 wells here, and you can define it. So then you can put in your seg-y file list for each of the wells like we've done in some of these previous utilities, or you can build the list right here by selecting this would give you output build this, so this would give you a chance to build the list. But if, like I said, the best way to kind of do this is input in the seg-y list file, you can just go build the list file and where you create the project, then you can just select all the seg-y files, build the list, and then you can input the list files into here. So you can do that, and it will output a single segy file in the. Now, granted, it's going to put the channels are going to be in the order of whatever you call well number 1 is going to come out as the first. If you have 3 12-level arrays, if you put whatever well you put the list in here for 1, it's going to come out as 1 to 12. Then this would be 13 to 24, and then 25 to 36, and you give it an output segue list name. You can also, if you already have a geophone files, like the RINF files defined for each one of these wells, you can select that, and it'll give you a chance to enter your .RINF file here as well, so that it kind of helps you combine 2 steps into one instead of having to go, concatenate the RINF files. That seems like a good place to stop for now. When I come back for the next video, I'm going to start with the prepare data option. So I'll see you guys for now.